Okay, good evening, ladies and gentlemen, and welcome to this Lean Six Sigma Black Belt Certification Hackathon. Now, because of some programs in this week, we have a little rescheduled this. Otherwise, this was supposed to be starting from tomorrow, but because there is a training program which is clashing in between, so we had to start Black Belt Hackathon today, and then we will start our regular, regular Monday session for all the new members if they want to, what you can say, continue, right? So first of all, for all the new members in the community, I welcome you. And why this? What is first of all hackathon? Let me explain you that, and then we will start the session. Okay. Now, how many of you are green belt? How many of you are yellow belt? How many of you are black belt? Can you just type in the chat box which certification you have already completed? Okay, that's your certification. Can you just type in the chat box if you have completed yellow belt? Just type YB. If you have completed green belt, just type GB. If you have already completed black belt, just type BB in the chat box. Everybody, let me see how many people are there in the. Okay, so if you are starting now, you can type yellow belt just now. Okay, because you have just completed yellow belt and starting the green belt. Okay, fantastic. So I think we have a lot of people who are yellow belt. Some of you have completed green belt. Okay, and yeah, so most of you are. So this session is actually for the advanced students, but I have invited all of you. The reason being, because anyway within next couple of months you will be covering these topics. Okay, so more you listen to these topics, more you will become familiar with those topics, and that's what I sent you the audio message in our group, WhatsApp group. Okay, so what is hackathon? Let's try to understand. I explained that briefly when we started this journey in 2021, online journey I'm talking about. Now, a lot of people used to take admission, but the completion of the certification was not happening. So, SNG team sat together and had a brainstorming about it. Why is this happening? Why are people delaying the examination? Okay, so then we designed this hackathon. In this hackathon, what we do, we cover the entire course, main topics, difficult topics, kind of revise them, all right, and then we push them gently, these people, to attempt the examination. All right, are you understanding? So after this, our the completion rate significantly improved after this strategy of hackathon. Okay, then we continued this strategy. Every 1 month we do the green belt certification hackathon. The second month we do black belt certification hackathon. So this month is for the black belt certification hackathon. Now, who can attend this? Who should attend this? Everybody should attend this. Okay. Why everybody should attend this? Because, as I said, it will be applicable to everybody, because within couple of months, don't consider green and black belt, even though they are separate certifications. Let's consider them a complete project, complete curriculum of Lean Six Sigma. Okay, so anyways, you have to understand what is design of experimentation, what is advanced hypothesis, what is advanced transformation theories and all this stuff. So today we will be starting the black belt hackathon. Ideally, the people who have completed their green belt have gone through the black belt course number 2, and they're ready for the examination. This is the best way. So let me quickly take you to whiteboard and explain you how actually ideally it should happen. Okay, so this is my whiteboard. Let me quickly take you through. Let's say for example, somebody takes admission on 1st of let's say Jan. Okay, they have attended the yellow belt, they have taken the admission for green belt and black belt, like most of you have done. Once their journey starts, so they will get the course access and they will start attending the live sessions every Monday and Saturday. Now, so self-study and the live sessions, so they continue, and within next 1 month, let's say this is 1st of February, let's consider that. Okay, and let me give another notification, which is 1st of March. So this is the 2 months of ideal situation. Okay, somebody who has taken admission in the month of 1st of January, let's say, this is a starting point, and at this point they are supposed to attend Green Belt Hackathon. I'm just in a short form, I'm just writing GB Hackathon. And so after Green Belt Hackathon they attend, then they can go for the examination. Now if it is matching their timeline, if the live hackathon is there, then they can attend the live hackathon, or they can attend the pre-recorded hackathon as well, which is already available in your course content. In your green belt course content, in your black belt course content, we have already given a pre-recorded, last month's hackathon recording is already placed over there. You can get that as well, and then you can attempt the examination. So I will write green belt hackathon plus examination. See, hackathon is nothing but it's a quick revision of all those main course content. All right, then after green belt the journey starts for the black belt. The black belt, again the same thing, within a month they can complete the entire course content, and then they can attend the black belt hackathon, and along with that examination. So this is so during this it is course like self-study plus the live coaching, okay, plus live coaching, which is happening at Saturdays and Mondays. So here also self-study plus live coaching. Are you clear, everybody? Just give me a yes in the chat box. So this is the framework, idealistic framework for all the members who are joining. So within next 2 months you should be targeting. So if you spend, as I said, 30 minutes every day or 2 to 3 hours every weekend, that is good enough for you to complete both the certification. And I always say this, certification is the beginning of the journey and not the end of the journey. Remember this, certification is the beginning of the journey. Okay, it's like when we graduate ourselves, like in engineering or science graduation or whatever, that is the start of our career and not the end of our career. Similarly, this certification is the beginning. We are learning theoretically, now we are ready to implement it practically in the real life situations. That's how it is. Okay, so let's start the let me just share my another one. Let me just quickly stop sharing this. And so black belt is course number 2 in your LMS system. Okay, most of the people, there are a lot of new people in the room right now. So I believe, see, we have a 9:30 orientation program, which I will explain you how you can navigate, etc. I will cover that. Right now, let me start the black belt. Now, this is the course 2. Course 1 is the green belt, course 2 is black belt, course 3 is master black belt. Remember this, okay? So this is the course 2 black belt hackathon. Now, here, if you scroll down, there is something. Now, this is very important. Just make a note of this. Every section in bracket, there is something like green and black belt common. Okay, now introduction to Lean Six Sigma, green and black belt common. What does it mean? It means it is already covered in the green belt. So in that case, you need not to go through it again. Okay, then why this is put over here? See, some people may not do this in continuation. Understand this. Some people, they will do the green belt, they will take a break maybe because of some reason. After some time, they will continue with black belt. For those people, this is the kind of arrangement we have done so that they can understand, they can connect the dots. That's why whenever you get green plus black belt common, that means this entire section has already been covered in the green belt. Okay, now here you can see in bracket where is exclusive black belt written, that is the content which is not been covered in the green belt. Are you clear with this differentiation? You can see here, define phase, green and black belt common. That means already covered in the green belt, you need not to do it again. Are you clear with it? Just give me C in the chat box, C for clear. For the new member, this is very important input I am giving you. Okay, when you go through this content, okay, why this is given, again I have explained you why this is given, because some people might get some gap in between. just to connect the dots. So you can see here. So Minitab is there, then again major phase, green and black. This is the common part of major phase, and there is a special part of major phase. You can see measurement system analysis. There is an exclusive black belt content is there. Then normality transformation, exclusive black belt content. Process capability, exclusive black belt content. Okay. Again, analyze phase. There is some part which is common between green belt and black belt, and there is an exclusive black belt content like advanced hypothesis testing, which is a black belt content. Advanced regression, which is a black belt content. Okay. Design of experimentation, which is exclusive black belt content. Again, improve phase. Similarly, it will go like this. Okay. So let's start our journey. I believe everybody is clear about it. Let's start our journey with Minitab. Can you open any blank Minitab worksheet? Let's begin with Minitab. Now today I will be covering only black belt exclusive content. That is also a little bit of difficult to understand, little bit of more explanation required. Those kinds of content we will cover today. Okay. Open any Minitab blank worksheet. All the new members, if you have not yet got Minitab, okay. Meanwhile, people, you can open Minitab and just type open in the chat box. Okay. Meanwhile, for the new members here, in the green belt and the black belt, you can see there is something called Meet Minitab. Okay, for the new members, remember this. Even in the green belt also, you will find the second section after define phase. Okay, this is a define phase. After define phase, there is a section called Meet Minitab. Okay, in Meet Minitab, the second option is Minitab download. Just click on the start button here. Just click on the start button, and this will only get downloaded in the laptop, okay, and not on the mobile phone. Okay, Minitab software is a heavy software. It will only operate on the laptop and not on your mobile phone. Now, laptop or desktop, any old laptop, desktop also will do that. We don't need any high fancy laptops. Okay, so here is the zip file. Just double click on this. It will get the files downloaded. Click on that. It will be, yeah, tab also will do. Tab also will do, Santosh. Okay, tab maybe chalega. Now done. So the people who are having this, super. Chalo. So open the fresh Minitab file. Let me share my screen with a blank Minitab file. Okay, so this is a blank Minitab file. Let's do one thing. We will generate, first we will start with central limit theorem. Okay, central limit theorem. Which link, Sunilji? You can just open the, as I said, you have to open course number 1 or course number 2, and there is a Minitab section. In that second section is Minitab download. You can get it from there. Okay. Super. So yeah, I hope you have the login ID password of this. Now, once you open the Minitab, let's do one thing. Go to Calc. Everybody follow me. Okay, can you just connect with our team? Can you just help Mr. Sunil? No problem, Santoji. You can just listen to this. Okay, Sunilji, just connect with us on our mentor number. Our team will help you out in that. Okay. या सुनील जी टीम आपको व्हाट्सएप के वो डिटेल्स भेज देगी हाउ यू कैन एक्सेस दिस. ओके, चलो. सी इफ यू डोंट हैव Minitab right now, if you're traveling, if you have this mobile phone, etc., just observe what we are doing. Okay, you will get the recording of this, so don't worry, you can check the recording and follow the instructions later. Okay, now everybody go to Calc, random data, normal. Everybody follow this path. Calc, which is calculator. In the menu tab, the fourth option is Calc. From the bottom, the third option is random data, and then it says normal. Just click on that. Calc random data normal. The moment you click on that, we will generate some numbers. So number of rows of data to generate, just type 5. Everybody follow the same instruction. Here, number of rows of data to generate 5. Then store in column. So now it is asking which column you want to data to be stored. So just type C1. C1 is column number 1. All right. Then we have the mean of the data and the standard deviation. Okay. So mean, either you can keep 0, which is there by default, but I am just putting 10. I'm just adding 1 over there, so it is becoming 10. I'm keeping standard deviation as it is. Okay. So I repeat quickly once again. Go to calc, random data normal. I am selecting 5 rows of data, 5 data points I want to generate. I want to store that in C1 column. I want the mean of the data, which is average of the data, as 10, and standard deviation by default is 1. I just click on OK. The moment I click on OK, I get some 5 random number generated. Everybody got this? Just give me yes in the chat box. You can see in the column number 1, 5 random continuous data numbers are generated. Clear? Everybody has got this? Just give me yes in the chat box. सबको मिला है? हाँ सुधीर जी, you got it? You got the सुधीर जी को आपने भेजा है? हाँ सुधीर जी, just check your WhatsApp first. First you get your Minitab fixed. Okay? इस exercise को आप छोड़ दीजिए. Just get your Minitab thing first, fixed first. Okay? And once it is done, then let me know in the chat. ठीक है? Superb. हाँ मैं फिर से बताता हूँ, एक बार फिर से करते हैं. ठीक है? Go to calc. Everybody click on calc, random data. You can see calc में, you can see the third last is random data. Slide your cursor on the arrow and you will find normal. Why normal? Because in the Six Sigma we are actually using normal distribution. That's why we are selecting normal. In the same list, there are multiple distributions are there, like chi-square distribution, multivariate distribution. You have F distribution, T distribution, uniform distribution, Bernoulli distribution, binomial distribution, and geometric distribution. There's so many distribution, and maximum we are going to use normal. Some of the distributions tomorrow we are going to use. Okay, I'll explain you. Hypothesis testing में मैं कुछ explain करूँगा आपको. Okay, यहाँ पे click on normal. Now number of rows, select 5. Column number C1 and mean is equal to 10. Mean 0.0 है. Just you can do it 10 or you can do it 0. You can keep it 0 as well. And just click on OK. The moment you click on OK, you will get 5 random data generated like this. Then your number could be completely different than mine. Got it? Very good. Yeah, everybody got it? The people who are following with me, just okay, just observe what we are doing. The new members, just observe what we have done is we have generated data from Minitab, random data generated. Okay, now let's repeat the same exercise for 50 data points, 50. Okay, how do we do that? Now understand this. If you want to do again, you don't have to go again for calc and random data. There is a short key available which is Control E. The short key is Control E, which is also called as Edit Last Dialog. Okay, or you can press Control E. The moment you press Control E, this box will appear once again. Just press Control E. Okay, now what you will do, instead of 5, just put 50. In column, now we are taking second column, C2 column. Instead of C1, just put C2. Just remove 1 and just put 2. That's it. And click on OK. So put Control E. Press Control E. You'll get this. Put 50 here and put C2 column here and press OK. That's it. Yes, done. So that's a practice for you. So you can generate random numbers like this. Now let's do it for 50,000 data. Now here you can see in the C2 column, you have got 50 data points. You can see here 50 data points have been generated. Okay, now let's do the same thing again. Control E. Now instead of 50 we will do 50,000. Let's do it 50,000 right now. All right, and we will make it into column number C3 and say okay. So in the column number 3 we have got 50,000 data points. You can see here 50,000 data points have been generated. Now what we'll do, everybody with me? The source of the data is randomly generated by the algorithm. Okay, they are randomly generated numbers. We are just giving, just like in Excel sheet, there is a there is a command which we give is rand between, which is random between, and if you give 0 to 10 and you generate the data, so Excel will generate random data. Similarly, we are giving what is the average and what is the standard deviation you want, and it is giving the data. Okay, 40k is the maximum limit, I think. No, it is not. 40k नहीं, इससे ज़्यादा भी जा सकते हो. You can go for 5 lakhs as well, but then it takes a little bit of time, so software becomes a little slow. Yeah, chalo. So what we'll do? Let's go to graph. Everybody with me? Go to graph and let's make a histogram out of it. Go to graph and click on the 5th option called histogram. Everybody follow this. Go to graph and click on histogram. Just click on histogram and this window will appear. In the graph option, the graph is file, edit, data, calc, stat, and then graph. The moment you click on graph and histogram, this window will appear. Now there is simple and with fit. Always select with fit, which is nothing but our with normal distribution curve. Okay, so just select with fit and say okay. So this window will appear. In the left side you have C1, C2, C3. All the 3 columns are there, and here you are it is asking graph variables. So now what you need to do is just double click on C1, C2, and C3. So I will double click on C1 first, then I will double click on C2, and then I will double click on C3, and then I click on OK. That's it. And here I have got 3 data points, 3 different histograms done for me. Everybody got this? See, your graphs might be a little different than mine because the data is different. Just how many of you got it? Just give me yes in the chat box. What I've done, I've just selected graph, histogram, and selected all the 3 columns where we have the data, and I just press OK. That means you can do multiple graphs in one shot. That's the best part of it. You don't have to do it one by one. You can do it all of them together, and it will create. Now understand this. Okay. Okay. The new members, are you enjoying this new way of new thing? Are you learning something new? This is what we practice every week, guys. Okay. So not to worry. Today is your first day. Some of you. Okay. So this is how we will practice every week. Every week we'll come live and practice these kinds of stuff, and you will become master in that. Okay. Super. Chalo. Now this is number 1. This is number 2, and this is number 3. Now my question is it normal distribution? Number 1, is it normal distribution? Give me yes or no in the chat box. Is this distribution normal? Let me draw like this. This is distribution like this. Is it normal distribution? Just type yes or no in the chat box. No, this is not normal distribution. This is called as skewed distribution. Okay. And because the tail, this is a tail which is extended on the right hand side, this is called as right side skewed, right hand skewed, RHS, right hand skewed distribution. Make a note of this. So if you have distribution like this is called right hand skewed. If you have distribution like this, it is called left hand skewed, where the data is paraded on the left hand side. Okay. Now coming back to the second one, is it normally distributed? This one, give me yes, no in the chat box, everybody. The second one, yes, no. Okay, some people are saying yes, some people are saying no. Okay, yeah, but is it better than the first one? Is it better than the first one? Just give me yes or no in the chat box. Is it better? Yes, it is better because majority of the data is in the center and less amount of data is towards the tails. That's the first indicator. And if I cut this into half, I will get kind of a symmetrical data distribution on both of the sides, right? So yes, it is better distribution than the first one. And what about the third one? Is it normal distribution? Okay, you got all in normal distribution. Fantastic, fantastic. It is perfectly normal distribution. Absolutely right. Okay, second one is also normal distribution. Okay, but third one is perfectly normal distribution. What is the difference between these three is the amount of data. So there is something called central limit theorem, CLT. Make a note of this. Central limit theorem. Central limit theorem says if you increase the number of samples in the data will start to take normal distribution shape. I'll give you an example. If you take, let's say, you remember yellow belt people, I give example of office arrival time. How many of you remember that example? When I explain the Six Sigma curve, I give the example of office arrival time. Yes? Remember that? Now in that example, if I take, let's say, one person's data or let's say two people data, I may not get this kind of a distribution, but if I take 30, 40, 50 people data and I plot their arrival like this, then I will get a normal distribution. So distribution is heavily depending on the sample size we have, number of data points we are dealing with. If we are dealing with less amount of data points, we may not get a normal distribution. And what central limit theorem says, more the data points, more the probability of getting normal distribution. And generally statisticians say minimum, write this down, minimum 30 data points you should have to achieve this kind of a structure. 30. If it is less than that, there is a lesser probability of getting normal distribution. Everybody please type 30 in the chat box. 30. Okay, let me type 30 as well. So let it go in your subconscious mind. Minimum 30 data points, you will get normal distribution, etc. So always we also suggest wherever you go for minimum 30 data points. Okay, yes, very good, super. Now let's do one thing. So we have got C1, C2 and C3. Okay, let's go to stat, basic statistics, graphical summary. Everybody follow this: stat, basic statistics, graphical summary. Stat, basic statistics, graphical summary. Follow this please. Stat, basic statistics, graphical summary. Just click on graphical summary. Now here C1 is a skewed distribution. C3 has got huge data, so it's a perfectly normal. Let's select C2 distribution, C2 column. So double click on C2, it will get selected in the variable. Just double click on C2 and it will get selected. Okay. And now you just click on OK. Yes, everybody got this number? Just give me yes in the chat box. This graph and the data. So what I've done, I went to stat, basic statistics, graphical summary. I just selected C2 column and said okay, that's it. This is the same histogram which we have just plotted. Same histogram. But so this is the same histogram. This is called as histogram. All the new members, you also must be aware of this. Correct? Now this is histogram. There is another graph here. What is the name of this graph? Type in the chat box. What is the name of this graph? This one. This is graph number 1. This is graph number 2. And this is graph number 3. Let's go one by one. Okay, yes, very good. Super. It is called as box plot. Okay, all the new members. This is called as box plot. This one. Okay, what is box plot? This is also a different distribution. Now, in the green belt level, you will come across all these, Pareto chart, histogram, time series plot, box plot. These are all basic stuff which you will cover. Now, in this box plot, this is called as lowest value. Okay, you can see here, this is the lowest value, which is minimum value of the data point. Okay, then this one is called as first quartile, or we call it as Q1. So you can see here, this is that value, quartile 1, which is 9.3. So this is that 9.3 value. This value central, this is called as median or Q2, quartile 2 or median. This is that value which is 9.987. Okay, and this value is called as quartile 3. So this is that value, third quartile, which is 10.719, and this is the maximum or highest value of the data set, which is 11.626. So this is how the box plot is constructed. Now, if the box plot is symmetrical, that is an indication that the data distribution is normal. Okay, for example, let's say if the box plot is like this, okay, the median line is the center and both the tails are equivalent. This is a normal distribution. Okay, if it is not normal distribution, it would look like something like this. Okay, it would be something like this. So this is where the skewed distribution come into picture. Okay, so this is also one of the indication. Everybody clear with this? Just give me yes in the chat box, especially the new people. Clear hai? Just give me yes. Okay, see, initially what I am talking about you might find a little difficult, but this is a green belt stuff. I'm not going into the details. Okay, green belt mein we have covered everything. Once you are going to that course 1, okay, you will get to know about what is box plot, how it is constructed, everything. Okay, now the third graph is 95% confidence interval. You can see here, this part is that. Okay, now let's try to understand what is that 95% confidence interval of means. Okay, so right now this data, the mean, which is average, x bar is the average, is 10.024. This is for the data average, which will locate somewhere here, 10.024. Now this is the average of the sample data. We have got 50 data points. N is equal to 50. Here you can see N is equal to 50, right? So with that 50 data points, your average is 10.024. Now here you can see 95% confidence interval of mean. What does it mean? Okay, everybody is aware of sample and population. Just give me yes or no in the chat box. Sample and population. Have you heard about this? Just give me yes or no. Have you heard about sample and population? Just put yes or no in the chat box. What is sample? What is population? No? Very good. Super. Now let's say, for example, there are 50 people sitting in the room. Okay? And SNG has got 10,000 students. Understand this. Sparran and Gavin has 10,000 paid students, and right now there are 50 people sitting in the room. So this 50 people group is a sample of the population of 10,000. Are you understanding? Yes. Now, after election, a lot of those survey people do the survey. Now, in the surveys, they don't go to everybody and ask, right? They go to specific pockets. They take some sample, right? So why do we do sampling? Because we cannot analyze the entire population. It is not practically possible. It is not viable. It is expensive as well. So we take a sample, and from the basis of sample, we predict the behavior of population with 95% confidence. Understand this. With 95% confidence, we are predicting that the population, the long term, okay, the mean of the population will be between 9.79 and 10.259. There is a range we are predicting, and there is a formula to calculate, by the way. So current mean is 10.024, but this is the sample mean. But for the population mean, that mean will be between 9.7 to 10.2. Similarly, the median, this is median, you can see 9.987. What is median? This quartile 2 is nothing but a median. Okay, this value. That is 9.987 for the sample. What they are saying is, with 95% confidence, we can say the median of the population will lie between 9.7 to 10.3. Again, there is a formula to calculate this. Are you clear with this? Just give me yes in the chat box. Clear? Everybody. Same has been given graphically over here. Same has been given graphically, mean and median. This is the third graph. Okay. Now this is the second column where a lot of people were confused that is it a normal distribution or a non-normal distribution. Some of you said yes, normal. Some of you said no, it is not normal. Now this is a test. This is a test which confirms whether the data is normally distributed or not, and that is called as AD test, or Anderson-Darling normality test. So Theodore Anderson and Donald Darling, these were two statisticians who have basically found out this test of normality, where you put the data and software will calculate a value which is called a p-value, probability value. If the p-value is, understand this, what is p-value? We are going to understand tomorrow, okay, in greater details. We will calculate it manually as well tomorrow, right? The p-value, if that p-value is less than 0.05, if it is less than 0.05, then the data is non-normal, which is nothing but skewed. If the p-value is greater than 0.05, then the data is normal. The P stands for probability value. Tomorrow I will cover about that, because tomorrow we'll talk about our hypothesis testing, advanced hypothesis testing. Okay, clear? So in this case, the p-value is 0.693, which is greater than 0.05. That is a confirmation that this data is normally distributed. Are you clear with this? Just give me yes in the chat box. Clear hai? Super clear. Everybody, anybody in the room who is completely lost that what is this happening, why I am here, ऐसा कोई है तो just type me in the chat box. And if you are very new and you feel like that, it is completely normal. It is completely normal, okay? Okay, there are few people who are honestly saying yes, it is me, who is a little difficult, finding it difficult, but don't worry. Whatever I have covered now, this is all green belt stuff, guys. Okay, this is not black belt stuff. This is absolutely green belt stuff. You will learn normality test. You will learn normality test in green belt. You will learn all these, box plot, histogram, and all these statistics. How to calculate mean, mode, median, standard deviation. everything will be covered in the green belt level. Okay, because you guys have not started this is your first day, that is the reason you are finding it difficult. But understand this, whenever you are a little confused and uncomfortable, that is an indication in your brain the new neural networks are being formed. Okay, new neural networks formation is nothing but uncomfort. So whenever we are uncomfortable, the new neural network is getting formed and we are learning something new. It's a good news for us. Okay, that's why I've invited you. I wanted you guys to become uncomfortable. Now the second time when you listen to this, you will be absolutely comfortable because you have already seen this. Third time you will be confident. Fourth time you will be absolutely confident. Fifth time you will explain to somebody. That's how you basically, okay? Mean, mode, median, 95% confidence. Yes. Can you explain the graph below the box plot mean? So this is the same plot basically. You can see here. This graph Dahlia, this graph is, let's say this 95% confidence interval of mean. So this spot is actually this mean value. So let me remove all these things, okay? So let's look at this graph. This dot, this dot is this 10.02. This is 10.024. Okay, and then you can see here the lower value is 9.790. So this is nothing but 9.790, and this value is 10.259. 10.259. Okay, again coming back to median, you can see here median is this one. Okay, median is 9.987. 9 point here, so you can see 9.987 is this value, center value, center dot. The lower side is here, you can see this one 9.75 and 10.31. okay, so here 9.75 and here 10.31. so the same numbers have been graphically represented. That's it. Okay, can you elaborate more on a square value? See, a square value is a value which is calculated. This value is calculated. So for us, you got it now? Very good. Thank you very much. See, for us, this value does not make any sense. Okay. Now, this is called as hypothesis testing. This normality test is also something called hypothesis testing. Okay. Now, what happens in hypothesis testing? We just take one distribution. It can be z distribution, t distribution, chi-square distribution, etc. Now here, what we are getting is there is some formula. First, that formula calculates that critical value. This a square value is called as critical value. For us, that value does not make any sense. From the critical value, we calculate the p value. Now that is done at the back end with the algorithm. Okay, so tomorrow I will give you a real example where you can also calculate it manually. I will give you some algorithms. I will give you some tables. From the table we will calculate manually how to calculate the p value. Okay? For us, a square does not make any sense. There is a formula to calculate a square, but for us it does not make any. We are interested in this p value. P value greater than 0.05, the data is normal. Less than 0.05, data is non-normal. Very simple. Okay, super. चलो आगे बढ़ते हैं. Yes, how many of you are, by the way, enjoying, even though some of the part are not understandable, but you guys are enjoying the process? How many of you like that? Just type me in the chat box. The first day people, okay, very fresh people, कुछ बातें समझ में नहीं आ रही है, फिर भी whatever is happening, it's you are learning something new. Yes, fantastic. And this is how the learning will happen. All right. Now, let me take you to one of the concept called measurement system analysis. Okay, super excited. Fantastic, Santosh ji, amazing. Thank you very much. Okay, chalo, let's talk about a concept. Now see, understand this. I am just covering the topics which are very, very kind of challenging to understand, a little difficult to understand. Okay, उतना ही मैं topic यहाँ पे cover कर रहा हूँ so that you will get some insight about it. Okay, now there is some science which is called as measurement system analysis. We call it as MS. Okay, Now, in Six Sigma, in the nutshell, what we do basically in Six Sigma, try to understand this. We reduce the variation, and by reducing the variation, we reduce the defects. Right? We reduce the variation and we reduce the defects. That is how basic fundamental of Six Sigma. Now, variation can come from lot of stuff. Okay. Now, to identify the sources of variation, you remember we have fishbone analysis, 6 M's. Analysis, we have got 6 M's. Man, correct? Variation can come from man, variation can come from machine, can come from method, can come from material, can come from mother nature, and in that there is something called measurement. What does that mean? We use lot of measurement equipments, measuring equipments, yes? We use thermometers, we use weighing scales, pressure gauges, speedometer, we use some softwares as well, right? Some vernier calipers or screw gauges. There are so many gauges, meters, etc., weighing equipments and measurement equipments we use. Now, measurement variation can come from there as well. So, measurement system analysis, MSA, is a science which quantifies variation coming from measurement system. So, what is the objective of MSA? To quantify, make a note of this, to quantify variation induced by measurement system. Induced meaning kind of introduce, measure, whatever variation is because of measurement system. Okay, induced by measurement system. Please bear with my handwriting again. So what is MSA? Measurement system analysis. Okay. Yes, very good. Total variation caused by apparatus and equipment. Fantastic. Very nice. So measurement system analysis is a science which quantifies the variation induced by the measurement. Now, if that variation, if total variation is 100%, let's say, out of which 10% is because of the measurement system, it is considered to be okay. They accept it. Okay. So, but we have to quantify it. Now, that's why the statisticians have given us two options. If the data is continuous, okay, exactly, very good. If the data is continuous, then we do gauge R and R, GRR study. And if the data is discrete, then we do attribute agreement analysis study. Now let me quickly touch upon what is continuous and what is discrete. There are two types of data. Continuous meaning the data which can be measured on continuous scale, that is called as continuous data, and the data which is counted or it cannot be measured, it cannot be expressed in decimals, that is called discrete data. Example I'll give. Continuous data is nothing but your height, weight, temperature, pressure, speed, all this data you can measure it on a continuous scale. For example, 10.8, 10.9, 10.9, 11, 11.1, 11.2, 11.3, 11.8, 11.9, 12. So on a continuous scale I can measure the length, height, width. It is a continuous data. And it can be basically shown or represented with decimals, expressed in decimals. Okay. On the other side, discrete data, it's kind of a count data. See, even in our day-to-day life also, we actually use this, but we subconsciously use this. I'll give you example. Whenever we go and so I'll write here. Whenever we go here, so measure. Okay, so here I will write. Whenever we do measurement, whenever we measure, that is a continuous data, and whenever we count, okay, that's a discrete data. So for example, male, female, go, no go, okay, pass, fail, how many pass, how many fail. So that kind of count data, okay, 10 people, 10 students were there, 2 students failed, 8 students passed. It's a count data, it's a discrete data. So you cannot have on a continuous scale, right? 1.1 student pass, 1.2, 1.3, 1.5, right? So measure and count. Let me give you an example. Whenever we want to whenever we want to say, like, go and count number of people in the room, go and count number of people in the room, we never say go and measure number of people in the room. Understand this? While for the weight, we say go and measure your weight, we say go and measure your height, we never say go and count your weight. See the difference? So subconsciously also, whenever we are measuring, it's a continuous data. Whenever we are counting, it's a discrete data. Are you clear with this? Just give me yes in the chat box. Clear hai? Very good. So 10 apples, so number of 10 is a discrete data. When it comes to kilogram, the weight, it is a continuous data. Clear? So number of apples is a discrete data, weight is a continuous data. Yes? Very nice. Now, in this case, what happens is, there is a global word. Now, measurement system analysis is very stringently followed in the automotive sector. Okay, it is very stringently followed in automotive sector, and there is a body called AIAG. Make a note of this. Let me just which is Automotive Industry Action Group, AIAG, which is nothing but a group of American automotive bodies or American automotive companies like Ford and Chrysler and the Chevrolet and all those, General Motors, GM. So all the big brands of US, they have this group called AIAG. There is a German brand which is called as VDA. Okay, so they together publish the measurement system analysis, what you can say, the norms, the standards basically they publish. Okay, so generally what they consider, so let me give you some basic guidelines. What they consider while conducting this study, okay, we generally take 10 samples. I'll give you an example of this. Okay, 10 samples, let's say for example, this is a pen. I want to measure the diameter of the pen. So I will take a vernier caliper, right? And I will take 10 pens like this. So sample meaning the 10 samples. So one pen is equal to one sample. So I will take 10 different samples just to check the variation in between. Okay. So I will take 10 samples and I will take, for every sample, I will take 3 readings or 3 trials I will take. So that means, let's say I take the pen, I will measure the diameter, I will note it down. After some time, the same I will do it again. I will measure the diameter, I will write this down. So I will do it thrice. So every sample I will test it thrice. And I will not be alone. There will be 3 people who will be doing this. So 3 appraisals will be there. Appraisals, nothing but you can see, let's say operators or quality control people. Okay, let's say, let me write in QC people. So 3 QC people will be there. So 10 samples, 3 trials and 3 people. So there are total 10 into 3 into 3, 90 data points we will basically cover. And then we will put that 90 data points in the software of Minitab, and then we will get some numbers. We will do it right now. Okay, so these are the basic concepts. Now let me explain you what is repeatability and reproducibility. Just make a note of this. Repeatability and reproducibility. You can see GRR, no? G stands for gauge, R stands for repeatability, second R stands for reproducibility. Okay? Yes? Yes, very good. Variation by appraiser and the equipment. Now here we go. So repeatability meaning what? Same sample, okay, with same equipment, okay, and the same person. Understand this, huh? Let's say I take the pen, equipment meaning the vernier caliper to measure the diameter. I measure the diameter, I write this down. Let's say the diameter is 10.1. I'm just giving you example. Second time the same pen I have taken, measure the diameter, it is coming 10.1 again. Third time again I'm taking the diameter, again it is coming 10.1. So I am repeating the same reading, and that is called as repeatability. Ability of the same person to repeat the same reading, it's called repeatability. Same person, same sample, same equipment, same person giving the same reading, it's called repeatability. When it comes to reproducibility, what is that? The same sample into same equipment but different person. Now the same sample is given with the same equipment and a different person. Let's say Dhiresh has done 10.1. Let's give it to Suresh, let's say for example. So Suresh also gives 10.1, 10.1, 10.1. Then it is given to, let's say, Yogesh. I'm just giving an example. So 10 point, again Yogesh also gives 10.1, 10.1, 10. That means all of them are reproducing the same result. And that is called ability of different people to produce the same result, called reproducibility. Now how do you remember this? How I remember this, my technique is very simple. Reproducibility and repeatability. A lot of people get confused. How do I remember? Reproducibility meaning different people. See, we are human beings. To reproduce a baby, we require two different people. Yes or no? A male and a female. Okay. So whenever it comes to reproducibility, remember that there are two different people required. Are you understanding? Repeatability, same person. Reproducibility, two different people. Are you understanding? Two or three different people. Clear? So this is the basic fundamental. Are you clear with this? Just give me yes in a chat box. Just take a screenshot of this. We will do a practical case right now. Clear hai? Super, super. Very good. Now just open that blank Minitab worksheet once again. Open the blank Minitab worksheet. Or the same Minitab worksheet also you can open. Let me open the existing one itself. Okay. So now if you are here now for the new member, let's say you are in the graph page like this, just click on this, or you can do Control Alt D. You will directly go to the data folder. Okay, so here is the data folder. Remember, we had created this these three columns of the data, right? Now first we will generate a worksheet for gauge R&R. Okay, first we'll quickly generate in 5 minutes, and then we'll do the analysis of gauge R&R quickly with the help of Minitab. We have to collect the data, feed that in the Minitab, and Minitab will give you the result, and we have to decide along with that. Okay, chalo. So let's find out. We'll go to Stat, Quality Tools, Gauge Study, create Gauge R&R worksheet. Okay, here. Everybody follow this. Stat, quality tools, gauge study, create gauge R&R, study worksheet. Just click on that. This will open. Everybody with me till now? Stat, quality tools, gauge study, create gauge R&R, gauge repeatability and reproducibility, study worksheet. Now once you click on that, this will appear. Now, so here there are three important parts we need to understand. Okay. What are the three important parts? The first one is called number of parts. These are the number of samples, which is 10, which we want 10, right? Then number of operators, so nothing but the appraisers, right? So we want 3. You can give them the name, like, right, Yogesh, Nilesh, Suresh, whatever you want to give the name. And clear? Now here number of replicates, etc. I'll explain you. So number of parts, so number of replicates is nothing but number of trials. So how many trials we want? We want 3 trials, right? So here you have to select 3. So number of parts 10, that is samples. Number of QC people or appraisers or operators are 3, and replicates are nothing but how many times you want to replicate. So we want to replicate 3 times, right? So 10 into 3 into 3, the 90 data points. So let's do this. So here what we'll do is, we will just put number of operators, the name of the operator. Let's say, let's give A, B, C. Let's give A and B and C, just for our simple understanding, okay? And replicate, number of replicates, just put 3. Go to option, let's see, okay, randomize. Here there is something called randomize runs and the operators. That means it will randomize it, okay? So we'll keep it as it is. Click on OK and click on OK. And here we have got a worksheet getting created. Okay, a worksheet getting created. So here I will write, so you can see here, this is part number, this is operator, and here you have to write your reading. For example, if I'm measuring the diameter, I will write diameter here. Now for example, the first run order, that means the first time, okay? You want me to repeat, Sunilji? Let me repeat. Go to stat, quality tools, gauge study, create gauge R&R worksheet. Have you reached to this level? Gauge R&R worksheet level, this level? Just give me yes. Okay. Now what I've done, I've just made 2 changes. By default there are 10 parts, by default there are 3 operators. I've just given operator name ABC, that's it. And number of replicates, by default there are 2 replicates, I have just increased to 3 replicates. Okay, and just click on OK, that's it. And then I got this value. Okay, got it? Now, so what I will do, first run. So let's say there are 10 pens like this. I will keep the first pen, fifth pen. Here you can see part number 5. I will give to operator A and I will ask him to measure. So operator A will take the vernier caliper and he will measure, let's say 10.1. I'm just giving you example. Then for operator A, I will give randomly second pen. He will measure 10.5. Then I will give the operator A the 7th pen. It will measure 10.2, etc. So it is random. Why random? To avoid the bias. Let's say if I give 5th pen again, 5th pen again, 5th pen again, what will happen? The operator without measuring will write 10.1, 10.1 and 10.1. Yes or no? And that is called a bias in the reading. And we don't want that bias to creep in. That's why we are randomly giving the pens. That is called randomization, to overcome the bias. Okay, so we will take all the readings and then we'll put this data into Minitab and Minitab will analyze it. Are you clear how to create the worksheet? Just give me yes in the chat box. Clear hai ye? Everybody with me? Just give me a quick yes. Super, super. Now I'm just giving you a file in the chat. Okay, just download that file. Now this file only will be visible and downloadable to you if you have laptop or desktop with Minitab downloaded. Then only you can open this, because it's a Minitab file. Okay? Once you open the file, let me know. Open. Meanwhile, as you are opening the file, so for the sample size, what we have done is the similar kind of data. Here there are operators Vijay, Yogesh and Manish. These are the three operators. And similarly, the 10 samples are randomly given, and this is the data we have calculated. Okay, the length or diameter, whatever is there. So this is the data they have. Okay, now we want to do the analysis. So go to Stat, Quality Tools, Gauge Study, Gauge R and R crossed. Everybody follow this path. Stat, Quality Tools, Gauge Study, Gauge R and R crossed. Now there are three options you can see here. There are three options. One is called crossed. One is called nested. Other one is called expanded. Actually, we are using crossed. Why crossed? There are three operators and there are 10 samples like this. Okay. So every operator is basically checking every sample, and if I draw this, it will look like, you know, cross like this. Okay, and that's why this is called a crossed one. Yes. What is nested one? When do we use nested? If we are using destructive testing. Okay. There are two types of testing. One is destructive testing, second is non-destructive testing. For example, let's say, let me give you a little mechanical example. Okay, for example, I want to check the tensile strength, for example, of this metal piece. Okay, endurance test or tensile. Let's say, for example, this is a tensile strength. And so what I will do, I will put this into a tensile testing machine. I will clip it to tensile testing machine, and this tensile testing machine will pull this entire piece of metal in both the direction, and that metal will start cracking in between here. It will make a crack. Are you understanding? Now, while this testing, this entire sample will get destroyed, and that is called a destructive testing. It will get destroyed. All right? Yes, you cannot use this sample, but for our diameter etc. measurement, we don't have to destroy the entire sample. We can use it again and again, and that's where. So whenever we are using the sample again, we go for crossed. Whenever the sample is getting destroyed, it is called as nested design. So we have to select nested. Okay. The third option is expanded. What is expanded? Now we are using only one parameter called diameter. Now if you want to check diameter in different temperature conditions, for example, okay, into hot condition, in normal condition, in in cold condition. So diameter is the major component, but it is tested against three different levels. Is called expanded what you can say testing or expanded gauge RNR. Clear? Crossed, nested, and expanded. Are you clear with this? Just give me yes in the chat box. Everybody clear with this? Cross. So right now we are using cross because we are using something called the same sample we can use again and again. So we are using this. Okay. Yeah. Which one you want me to explain once again? Crossed. See, diameter, the same pen we can use it for the other people, right? That is called as crossed study. Why it is called cross? These are the people. So these are the QC people and these are the samples. Okay. So there are 10 samples now, 1, 2, 3, 4, 5, 6, 7, 8, etc. And these are the three operators we have. So person 1 will check all the 10 samples, right? Person 2 also will take all the 10 samples because there is no change happening for the sample. We are just checking the diameter, that's it. Sample will remain intact. And if I draw this graph, it will look like this crossing with each other. No? That's why it is called crossed. Okay. Nested and expanded is recommended. We never use or extra care is required. Yes. So nested is for destructive testing. That's what I'm saying. If you are using every sample, the standard sample, but the sample is getting destroyed during the testing, that's time you have to select nested. Okay. And expanded, when do we use expanded? You want to check the diameter in various, so we are adding another dimension, which is, let's say, temperature. We are using temperature is another dimension. So diameter under various temperature if you want to take, that is called expanded study. See, one is only diameter testing. Another study is diameter in various temperatures. Diameter, in various, conditions. That is called expanded study. Clear, everybody? Cross, nested, expanded. This is just for your information I'm just giving you. Clear? So crossed and nested and expanded ke liye, when we will discuss about design of experimentation, I will explain you generally for expanded what do we do basically. ठीक है? Good. चलो आगे बढ़ते हैं. Now once we get the data, let's analyze the data. Stat, quality tools, gauge study, crossed. Just select crossed. Now in part number, select sample, operator, select operator, and measurement data, select size in mm. Okay. Just select 1, 2, 3 like this option only. Select 1 in 1, 2 in 2, and 3 in 3. Okay. And select X bar R and click on OK. All right. Now, once you get this, everybody got this? Just give me a chat box. Not getting the graph? I'll repeat again. So go to Stat, Quality Tools, Gauge Study, Crossed. In the part number, select sample. In the operator, select operator. Measurement data, select size in mm. Method of analysis, select ANOVA and X bar R. We'll understand ANOVA tomorrow. Okay. So right now just select X bar R, which we have already seen. Okay. Let's go to gauge info में क्या है? Okay, नहीं है. Options में क्या है? And click on OK. आपको ये करने के बाद ग्राफ नहीं मिल रहा है क्या? Go to the graph option. Done ना? Okay. Yeah, otherwise you just click on graph option here and you will get this graph. Okay, now let's quickly understand what this graph is all about. See, what we are interested in, this is what we are first graph what we are looking. Okay, so here there is something called gauge R and R, and there is something called part to part. Just try to understand briefly what does it mean. Gauge R and R, you remember R and R stands for repeatability and reproducibility. Okay, so this plus this becomes the total GRR. So repeatability plus reproducibility become the total GRR, and this is part to part variation. Now try to understand this. Okay, if this is a total variation of the process, okay, there is some actual variation between sample to sample. Now for example, if I take 10 pens like this, just try to understand, this is very interesting. Okay, now every pen really has different diameter, yes or no? Okay, one pen will have 10.1, another pen would have 10.2, another maybe had 10.0, 10.2 again. So really, pen to pen, there is actual variation of the diameter, and that is nothing but called as part to part variation, which is actual variation. Are you understanding? Now the second one is called gauge R and R. Now while measuring, okay, while measuring this with the vernier caliper or screw gauge, etc., while measuring also some kind of error, some kind of variation can induce. Okay, and that induced variation is nothing but GRR variation. What statisticians are saying, if this is 10% or less, it is good. Total variation say 10% hai, that's a good thing. If this graph would have been like gauge R and R etc. would be more and part to part would be less, like this is part to part, then this is rejected gauge, because that means gauge R and R, the gauge variation is higher than actual sample to sample variation. How many of you got it? Just type yes in the chat box. How many of you got it? Just give me yes. Focus here guys, focus. Got it? Again, let me explain you this. Okay, see, there are the data, there are 10 pens like this. So actually also there would be variation between each and every pen, because variation is nature of nature. Variation is ingrained in the DNA of the process. Okay, so there will be variation, sample to sample, part to part, pen to pen, there will be actual variation. Okay, and that is actual variation which is present. But apart from that, while measuring also we can induce some additional variation. Are you understanding? So that by default whatever variation is there, that is called as part to part variation, pen to pen variation, sample to sample variation. Okay, and whatever variation induced because of the equipment, that is called as gauge R and R. Okay, while measuring there will be some, how I am measuring, how other person is measuring, whether that equipment is kept properly or it is tightened properly or it is kept loose. So there will be some measurement related variation getting induced, and that is called as gauge R and R. Now ideally gauge R and R should be less and part to part should be higher. If it is ulta, if it is reverse, then that study is rejected, that gauge is rejected. Process variation, actual variation is actually part to part variation. Yes, you can say that. The variation coming from other factors, other process parameters. Okay, but while measuring, there are some variation getting induced, and that is what is part to part. Okay, how to add the data? Prabhakarji, you understood how to add the data now, or you want me to repeat again? The same data which I have given you, you open the file and do this. The file I have given the chat, right? This is the file. This is the data basically. This is the data. Once your data is there, go to Stat, Quality Tools, Gauge Study, Gauge RNA Study Crossed, and put sample operator size. Click on X bar R and click on OK, and you will get this graph. Okay, now, so this is one what you can say good aspect, that this is under the control. Okay, now let's check the statistics of this. How do we check the statistics? Just go to Control Alt M or this sessions folder. You can see my cursor, sessions folder here. Now once you click on the sessions folder, just scroll it up. Now what we are interested in, there are three elements we are interested in. Okay, what are those three elements? Just try to understand this. The first element is, let's look at this. This is the first element. Okay, if the total variation is 100%, just try to understand this. Everybody could find out these statistics. You can find out over here. Just click on this area. No, this is already the moment you give these cross study na, this is already done at the back end, Kiranji. The moment you get the graph at the back end, this graph is done with this calculation. Okay, just click over here and you will find. Just scroll it up. First click and then scroll it up. You will get this kind of data. Okay. Now, got it? Let me know once you are done. Why the values are not matching? I'll tell you. Because you have selected ANOVA. Now, okay, you have selected ANOVA here like this. Now just go back. Just press Ctrl E and just select X bar R and click on OK. Then you'll get the same value. Just do it right now. Got it? If you have selected ANOVA, then you will get a different, because we have not covered ANOVA. Tomorrow we'll cover ANOVA. That's why I'm just selecting the basic X bar R. Okay. Right now, so just focus. There are three elements we are interested in. The first is, you remember the graph X bar, GRR and X bar R, okay, part to part. If the total variation is 100%, the GRR variation is 2.36. So if it is less than 10%, the gauge is passed. It is called percentage contribution. Okay, so this is the first indication. So if it is less than 10%, the gauge is passed. Second is this value. What is this value? It is percentage tolerance. What is percentage tolerance? If this is also less than 10%, that means the gauge is passed. What is this tolerance? Tolerance meaning LSL and USL. Okay, how that gauge is performing against USL and LSL. So that is that percentage tolerance. Tolerance is nothing but that range of LSL and USL. Against that range, how this gauge is performing. So it should be less than 10%. So it is 8.41. So there are two positive indicators. The third indicator is number of distinct categories, or NDC. Now NDC is 9. Now there is a formula to calculate NDC, but what is number of distinct categories? Let me give you one simple example just to understand this. Okay, let's say I have got a measurement system which is only showing, just try to understand this, which is only showing low and high. I have got a gauge which is only showing low and high. Okay, like for example, in our car dashboard, now some very old cars, we used to have when the petrol used to go down, then there used to be a red indicator, right? So it was low and high kind of indicator, only two variables. So in that case, number of distinct categories are 2. So NDC will be 2 in this case. If I have low, medium and high categories, my NDC is 3. If I have extremely low, medium, high and extremely high categories, my NDC is 5. It is equivalent to least count. How many number of distinct categories you can basically do, and there is a formula to calculate it. Okay, so what is the good gauge? Any NDC equal to or greater than 5. Equivalent or greater than 5 is a gauge acceptable NDC. So right now, percentage contribution less than 10, percentage tolerance less than 10, and NDC greater than 5, all the 3 categories are passed. That means the gauge is passed. We can collect the data from the same gauge and we can go for the further study of the process. Then we'll move to man variation, machine variation, method variation, etc. Once the measurement variation is fixed, then only we should consider the other parts of the variation. Are you clear? And this is called as measurement system analysis study. Are you clear with this? Just give me yes in the chat box. Clear hai ye? Super. Very good. Okay. How many of you are feeling bheja fry right now? Just type me in the chat box. Okay, this is very simple. You just have to remember, okay, only once. All right? Yes? See, initially it looks like this. Okay, initially it looks like this. But that is the power of the statistics. Now, that's where we basically enjoy. That's our specialty, right? We can understand the complex topics. Okay? Can you please repeat? Okay, difference with respect to tolerance and other one. Okay, see, understand this. Okay, I'll quickly explain you this, and then we'll take a quick 5-minute bio break. Okay, we have already covered 1.5 hours, and a lot of people have not understood. Okay, yeah. So let me explain it quickly once. What we have done, first we have created the data collection worksheet. Okay, the 3 samples, 3 people, 3 trials, etc. We created the worksheet. Then we have collected actual data by measuring it. Once we collected actual data, then we have started analyzing it. For analysis, we have selected the crossed one, correct? Gauge R&R cross study, right? Once we selected the data, put the data, Minitab has given us a graph. So the first graph we have selected, this one, this graph we have seen, this graph in which gauge R&R graph should be lesser than the part-to-part variation. Okay, that is a very good positive indicator. Then we'll go to the statistical analysis. In this, there are 3 components very important. One is called percentage contribution. What is percentage contribution? Let's try to understand. Let's say if this is the total variation of the total variation, out of which because of gauge study only 2.36% variation is contributed because of gauge study. Remaining 97.64% is because of other variables which will be man, method, material, okay, and what you can say, machine, and all the other factors. 97% contribution, 97.64% contribution is because of the other factors. 2.36 is because of the what you can say, the actual measurement variation, which is well below the allowable limits. Okay, yes, are you clear? No, this is the consider variation. Consider variation. What is variation? Well, let's consider variation as standard deviation or variance or the range of the data. These are the measurement, right? So in that contribution, 97.64% is because of the other, and 2.36 is because of the this one, okay, because of the gauge RNR. Now the second one is against the tolerance. Now what they have done, they have put the specification limit. They have put the specification limit. Now here, where have we put specification limit? I will show you. Once you go back to this data, go to option. Okay, here you can go to option. Here you can see upper specification minus lower specification is equal to 1. What does it mean? Let's go back to data. Let me just give you one quick indication about it. Let's go back to data. Now data, as you can see here, data is approximately averaging around 2.5 mm. Okay, just try to understand this. Now what they are saying, they are putting lower specification and upper specification limit. So this is my mean. My lower specification is, let's say, 2.0. My upper specification is 3.0, and this is my actual variation, like this. Okay, so against this, you know what you can say, against this specification limits, if I put specification limit, that is nothing but a tolerance. Okay, then now we'll go back to this. So against tolerance, this one, against tolerance, if I put tolerance, what is the percentage variation we are observing? Now this should again be, it should be less than 10%. Right now it is 8.41. Again, there is a formula to calculate this. Okay, our point is just check whether it is less than 10%. Correct? And then the number of distinct categories, as I said, again there is a formula to calculate NDC. Okay, right now it should be greater than 5. It is 9, so we are accepting the gauge. Clear? Super. So let's do one thing. Let's take a quick break. It is 8:35 right now. We'll be back by 8:40. Okay, we'll cover some additional stuff today. Okay, today I'm going to cover triple A also. I'll take one example, and then normality theory I will cover quickly, and then we'll close the session. Clear? Okay, वेरी गुड. 8:40 को आते हैं वापस. ठीक है, चलो. Okay, everybody's back. Just give me a confirmation in the chat that you guys are back. Let me take a couple of questions here. Very good. Just type yes in the chat box if you're back on your seat once again. Why gauge R&R has to be less than 10%? See, Prabhakar ji, 10% is the ideal value. Okay, it's an ideal value. Sometimes, now again, it depends on your what do you say, your equipment or your industry. Okay, let's say imagine you are working in the precious metal industry. Let's say you are dealing with gold. In that case, your gauge R&R, I would put 1%. Because in gold, even 0.0001 also, it would be a huge number, right? It's very expensive metal. So it depends on, so 10 is a very, what you can say, commonly used percentage in gauge R&R. In some cases where, measuring equipment is not really, let's say scrap. Okay, what you can say, scrap dealer people. Now those people, do not care in grams. They take the weighing scale into tons, and so in that case even 25-30% gauge R&R would be acceptable to them. Okay, so it depends on what is the criticality. So if you are dealing with precious metal, if you are dealing on pharmaceutical cases, etc., where gauge R&R norms are very strict. Okay, super. चलो आगे बढ़ते हैं. So let's quickly talk about the next one, which is called as AAA. So I'm just sharing a file with you. Just open that file. File name is AAA. If you remember, it is attribute agreement analysis. If you have discrete data, then you have attribute agreement analysis. Okay. So let's open the file, and once it is opened, let me know in the chat. So I'm just sharing my screen. Meanwhile, the moment you guys are opening the file, let me explain you the scenario. Okay. Now this is the file. Let me just quickly make it a little, yeah. Just try to understand the scenario here. Let's imagine now this is a discrete data, yes, no, pass or fail. Let's say there is a service industry. Let's take a service industry example. Now we have taken, let's say, manufacturing industry example. Let's take a service industry example. So there is a bank and there is a credit department, okay, loan department for example, and now they have received 10 files. So every file is a sample for them, and there are 3 credit managers, officers, I would say, officer A, officer B, officer C, and every loan file is given to them to check, and they have to decide whether it is accepted for the loan or rejected for the loan. Accept or reject. This is what they have to basically finalize. All right. So here you can say first sample, let's say, okay. The first officer is saying no, N meaning no, Y meaning yes. Officer A, again, second time he is also saying no, third time also saying no. Officer B also saying no, no and no. Officer C also saying no, no and no. Now there is something called truth here. What is truth? Truth is nothing but a standard. See, when we are saying yes and no, some discrete data, there has to be some standard. There is some senior person who should have the final authority. Like now, whenever we have some debate going on, there is a judge, right? Right? Somebody said yes, somebody said no, but there is a judge, one judge who decides who is right and who is not. So truth is nothing but maybe a senior manager or a head of the department, of the loan department. His say will be the final say. His decision will be the final decision. For example, if he is saying no, that means that file is rejected. Okay, so that we can compare the whether how much accurately people are performing against the truth. Okay, that also we can calculate. Now, you remember repeatability and reproducibility, right? Repeatability meaning the same person checking the sample again and again, giving the same reading. Okay, and reproducibility meaning multiple people giving the same reading. That is called reproducibility. Now let's find out repeatability and reproducibility manually. find out that. So let's find out this. Officer A, okay, I'm talking about the first sample, all right. Officer A, he's saying no, no, and no. That means he's repeatable, okay. So one is repeatable. Second is yes, yes, yes. Third is no, no, no. Fourth is yes, yes, yes. If I consider all these things, yes, 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 no, 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 yes, 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 etc., I would say officer A is 100% repeatable. So repeatability is 100%. Just observe this. Now you people just check officer B and officer C and tell me what is the percentage of repeatability for both these officers. Type in the chat box. For officer B and officer C. Let me just demarcate like this. This is officer A, this is officer B, and this is officer C. Now you can just check out. Okay. Officer A is 100%. What is officer B and officer C? Just count it. Just check how many times they are disagreeing to themselves. And we have total 10, right? So you have to just multiply that by 10. If they're right in 9 times, so multiply that by 10, that is 90%. Yes, officer B is 90%. Everybody got the same answer. Only he is failing in the final one. Can you see here? So 90% of the time he is repeating with his own reading. Yes or no, everybody? What about officer C? Officer C, yes, absolutely right. So officer C is 80%. 80% of the time. Officer C is failing here. In the 9th option he is failing. He's saying yes first and then no and no. And he is failing the second time. He's saying yes and again no and no. Otherwise he's saying the constant. So officer A is 100%, B is 90%. And C is 80% repeatability. Are you clear with this? Everybody clear? Repeatability. Manually we have calculated repeatability. Clear? Just give me yes in chat box. Very good. Now let's find out reproducibility. What is reproducibility? Remember, all of them should say the same thing. Okay. So let's find out sample 1. Even one says different, then the reproducibility is failing. Okay. Let's say no, 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 no. So everybody is saying no. So this is passing the reproducibility. Okay. Second one. Yes, 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 yes. But here there are a couple of no's here. So this is failing. The third one is also failing. The fourth one is yes, passing this. Fifth one is also passing. The sixth one is also passing. Seventh one is also passing. The eighth one is also passing. Ninth one is failing and 10th one is failing. That means we have 60% reproducibility rate. Are you understanding? So 100, 90 and 80% of repeatability personally, every individual wise, and 60% of total reproducibility rate we are getting in this example. Clear? Just give me yes. Now here, instead of gauge R&R, there is something called kappa value. What is that? Kappa value. So that kappa value, I'll show you how to calculate the kappa value. Go to stat, quality tools, attribute agreement analysis. Just follow this AAA, because this is a AAA example. Stat quality tool attribute agreement analysis. Just follow this. Stat quality tool attribute agreement analysis. Click on that. Now here there are options like attribute column, samples and appraisals, and the second option here is multiple columns. Now because because we have data in multiple columns, just click on multiple columns first. Okay, I repeat again, go to stat, quality tools, attribute agreement analysis, click on that, select multiple columns. The moment you select multiple columns, click in this space. And this is the most important part, focus here. Click in this space. Now you have to select. Now you have to select between C2, remember this, C2, shift, press shift button and C10 column. So what you are selecting actually, C2, C3, C4, C5, C6, C7, C8 and C10. Up to C10 column we are selecting, and click on this select button. They will all get selected. I will repeat again. I just remove this. I just click on Officer A trial 1. I press shift and then Officer C trial 3 and just select. They are all getting selected. Then number of appraisals. Number of appraisals, there are 3 appraisals. Number of trials, there are 3 trials. Appraisal names A, B and C. I'm just giving A, B, C name. The known standard is nothing but, if you click on this, just double click on truth. Okay, now everybody just follow this. Multiple columns, select this. Number of appraisal 3, number of trials 3. Appraiser's name ABC, that is optional. If you don't want to give it, leave it. Known truth, known standard is a truth. You remember the last column is, final column is truth. Select that option and click on OK. And there is a graph. Okay, just let me quickly explain this graph, but we are interested in the this kappa value, right? Let's look at this graph. This graph says this is the repeatability score. And this is accuracy of repeatability. I'll explain both this. Okay. What is repeatability? Remember the first one we had 100% repeatability, second one 90%, third one 80%. Remember that? Just give me yes in chat box. And this is nothing but 95% confidence interval. We just spoke about it. These lines are nothing but 95% confidence interval ranges. And there is a formula to calculate. Okay. Second one is accuracy of repeatability. What does it mean? This means, you remember the truth column? Okay, so here this is within the appraisal. Now here we are comparing how much accurate you are with that standard. In this case, the first person is 100% accurate with the standard, second person is 80% accurate, and the third person is 80% accurate again. So with this basic graphs, what we are understanding is, first person is having good reputation and good accuracy, while second and the third person require some more practice or some more knowledge in judgment. Clear? Itna samajh mein aa gaya? Just give me yes in the chat box. Yes, their 80% has to increase. 80% has to go to 100%. Clear with this? Just give me yes in the chat box. Very good. Now we are interested in gauge R&R value. Where we will find that? Go to the statistics here. Okay. Click on the sessions window and you will find fleece kappa value here. You can see the kappa value here. 0.78. Okay. This is called as fleece kappa. So fleece is the name of the statistician and kappa is basically a value. Kappa is basically Greek letter, just like sigma, delta. Kappa is a Greek letter. So this value is 0.78, right? 0.78. Now understand this. 0, so 1 to 0.9 is excellent kappa value. Okay, 0.9 to 0.7 is acceptable, still acceptable, and 0.7 below or less will be, it needs improvement. So ours is acceptable region. Our kappa value in this case is acceptable region. So our number second officer and third officer, officer B and officer C, requires some improvement, some training, coaching, guidance, etc. Once their performance improves, our kappa value also will improve. Clear? Just give me yes in the chat box. If, understand this, if 100% repeatability and 100% reproducibility, kappa value will be 1. If we get 100% repeatability, 100% reproducibility, kappa will be 1, which is excellent. Clear? That is the ideal situation. But otherwise, there will be some variation over here. Okay? Got some idea about how the gauge R&R and kappa AAA has to be is basically done? Yes? Super, super. Now let me share a transformation. एक टॉपिक हम लोग कवर करते, then we'll close the session today. Okay? The topic we are going to cover is called transformation. What is transformation? Just in the first case, we have seen the normal distribution data, the central limit theorem, right? And we have seen some skewed distribution as well, right? Now, what if a skewed distribution data comes? How do we handle that? That is the question. How to handle the skewed distribution of the data? Okay, so open this file which has been given and just type open in the chat box. Now we will just understand some of the skewed distribution data. Okay? What will happen if a skewed distribution data comes? So open that file which I have given to you. Let me close the rest of the files right now, otherwise, yeah, you can just close the remaining files, otherwise you will get confused. Okay? Once you open the file, please let me know. The name of the file is called log transformation. Open? Very good. Let me open. Okay, meanwhile, the normal distribution data we have already seen. Let's figure out a skewed distribution data. Okay, let me open the file and we'll first make a histogram. So let me open, yes, here we go. So this, let's understand what is this data all about. This data is, there are some pathology tests they are doing. Okay, some chemical testing, some kind of pathology testing, and for every test, how many minutes they have taken. For example, first they have taken 210 minutes, second test they have taken 300 minutes, third test 40 minutes, etc., etc. Now for this column, if I want to check whether the data distribution is normal or not, we'll go to graph and histogram and find out whether it is. Just do this. Just make a histogram out of it. Now this is a histogram. If you clearly observe, you can see a pattern like this. Which is nothing but right hand side skewed. Everybody got this? Just make a histogram of the time column. You will find a right hand side skewed data. Just give me yes if you got this histogram. Okay. Let's do the statistical analysis once again. Go to stat, basic statistics, graphical summary. Remember that we have done that. Stat, basic statistics, graphical summary. Just click on that. Select time column and click on OK. You will see Anderson-Darling normality test. P-value is less than 0.05. That means the data is non-normal. Your box plot also is shifted on one side. Just give me yes if you are observing all these traits. So your histogram is also showing this, your box plot is also showing this, your p-value is also confirming that the data is non-normal. It's a skewed distribution. Clear? Now in that case, how do we handle this? Okay. So there is something called transformation we do. How do we do transformation? Let's try to understand the procedure. This is a little complex procedure. Okay, मैं एक बार explain करता हूँ how do we transform the data from normal to non-normal to normal. Okay, एक बार understand करिए. First, go to stat, control chart. Just follow this procedure. Stat, control chart, box Cox transformation. Okay. See, most of you are new members. Just maybe just forget about doing along with me. Just observe whatever I'm doing. Okay, don't follow with me because you will get confused. Okay, just follow. Stat, control chart, box Cox transformation. I click on that. Okay. Here, all observations are in one column. So this is, I'm selecting time. And I'm clicking on OK. Okay, I have to write subgroup size. Okay, I'm just giving subgroup size 1. Just observe what I'm doing and say OK. Now there is some plot has come. What I'm interested in this value called lambda. If the lambda value is 0, so this is called lambda and the value is 0.00. So this is the value I have taken. I quickly repeat whatever I have done. I went to stat, control chart, box Cox transformation. This is one of the transformation strategy. I select time over here, put one subgroup size. That means every data is individual data, and click on OK. The moment I clicked on OK, I got this graph and a lambda value is 0.00. So I take this value and I go to a table. And this is a table which is given in your curriculum. Okay. And all the curriculums are downloadable curriculum. You can easily understand it. Now here is the lambda value 0. Transformation suggested is log transformation. Okay. So what it is, y meaning the data, whatever data, the time column data is y. So instead of that data, because that data is non-normal, you take the log value of the data. You take the log value of that. Now what is log value? How many of you remember log tables? How many of you remember log tables we used to use in our school days and college days, 11, 12 standard, etc. Science student, engineering student, etc. Log tables yaad hai sabko? Some of you must be remembering. Just type yes in the chat box. Now what is log? Just try to understand. Okay, let me just take it on the white one. Let's say 10 raised to 1 is equal to 10. Okay. 10 raised to 2 is equal to 100. 10 raised to 3 is equal to 1000. We all know this, right? Now understand this. Log of 10 to the base 10, okay, is equal to 1. Just try to understand this. Log of 100 is equal to 2, of course, to the base 10. Log of 1000 is equal to 3. So these are actual numbers and these are the log numbers. So if actual number is 10, I will not take 10, I will take 1. If actual number is 100, I will not take 100, I will take 2. Are you understanding? That is called the log. Clear? So we have to convert this log and then we have to check whether it is normal distributed or not. How do we do that? let's go back to the Minitab software. Okay, this is the data. Now go to the calculator. Now here is a catchy part. Just I'll do it. Just observe what I'm doing. Go to calculator. Okay, go to calculator. Yeah, in between values also it will calculate. For our let's say for example, if the value is 40, so that let's say log 10 is what, 1, right? Log 100 is 2. So log 40 का log कितना होगा? 1.2, 1.3 ऐसा कुछ तो होगा in between. Okay, let's do it so you'll understand. Now store result in. So what it is asking, store result in which column? Let me put C5. So I will put result in C5 column. Now here in the expression I am selecting a logarithm in the function and I am double clicking on log base 10. Double click on log base 10 and then here I am selecting time. Okay, what I have done, I have just made 3 changes in this box. Repeat again, I am just closing this. I go to calculator. I will select the column C5. Okay, I go to function. I am selecting logarithm function. Okay, double click on log base 10 and double click on time. The moment I do that and click on OK, I have got this entire values. Now let me give the name log. Now try to understand this. The value, actual value is 210. The log value is 2.3. Actual value is 300. The log value is 2.4. Okay, let me share actual value 100 है क्या यहाँ पे कोई okay, yeah, you can see actual value is 100. Here column number, row number 60. Actual value is 100. The log value is 2. Are you understanding? So what we have done, they have calculated the log value separate. Now you can do the same thing. Let's go to stat, basic statistics, graphical summary. Now you select the log variable, click on OK. Wow. Can you see here? Earlier was a skewed distribution, now it is, and look at this Anderson-Darling normality test p-value. Okay, let's compare this side by side. Histogram बनाते हैं. Select time and select log and click on OK. Look at this. ये है time वाला and ये है इसका वाला. ठीक है? See, side by side you can see and compare how was the earlier distribution and now it is looking symmetrical distribution. And this is how the transformation of the data is done. Mind blown? Okay, fantastic. Clear? So I think we'll stop here today. It's been very heavy session today. Okay. So everybody clear with this? Just give me a suggestion. Again, it requires the 3P formula, right? Anything you master, you want to master, you become master. Always remember the 3P formula. What is 3P formula? What is the secret formula of 3P? Practice, practice, practice. Okay? Practice, practice, and practice. Yeah, why should we do the transformation? Because you remember all our calculations are on the basis of normal distribution. Normal distribution. Okay. Now, if the data distribution itself is not normal, all our calculations will be going. See, normal distribution calculation meaning what? The area under the curve, distribution curve. Okay, it is based on a symmetry. If the symmetry is not there, our calculation would go haywire. Okay, tomorrow we'll understand this topic very clearly, because tomorrow we are going to cover hypothesis testing. We'll cover manually how to calculate p-value, etc. That will be amazing experience for you, and you will learn a lot of things. Okay, so today we'll stop here. I will upload the recording in the Black Belt Hackathon, right? So check out that, and we'll connect tomorrow again at 7 p.m. sharp with the other kinds of details. Okay. So till the time, thank you very much for joining. We have a second session coming up at 9:30, immediately after, just 10-15 minutes from now. This is for the new members, okay? And of course, everybody can come, and we will see how you have to basically start. Okay, that will be not more than half an hour session. So 9:30 to almost 10 o'clock, we will cover that, and then we will check. Okay. To join Black Belt session, see, Santoshji, live sessions are not mandatory for everybody. Meaning, you can do your self-study. The course content itself is self-sufficient. Okay. But if you want to learn more, some deeper concepts, okay, then live sessions, you are most welcome. You can check the recording. If you have some meetings, etc., some time is clashing and not able to, you can check the recording. Okay. Super. Thank you very much for joining. We'll connect again for the upcoming session for the new members. It's an orientation session at 9:30 sharp. Okay. Bye bye. Take care.